In section 1.1, we're going to deal with solving equations. So before we get started, here are all the properties of equality. You've probably gone through these in algebra and probably geometry a little bit too. I think these are a good thing to have written down, so I would recommend copying down this chart, just having these in your notes, and then we'll move on from there. In our first example, we're going to just solve a simple multi-step equation. Here, I want to solve for y, and my equation is negative 27 plus 6y equals 3 times y minus 3. So basically, what I'm trying to do here is I'm going to combine like terms, and I'm going to get the y by itself. So right out the gate, I see that I have parentheses, so I'm going to want to get rid of those. One way I could do it is by distributing, but another way I could do this is to divide both sides by 3. What's going to happen here is the 3 on the right side is going to cancel out, and then I'm just going to divide each term on that left side by 3. So that negative 27 is going to turn into negative 9. 6y over 3 is going to turn into 2y. So now I'm left with negative 9 plus 2y equals y minus 3. So from here, I want to get all my numbers together and all my y's together. I'm going to add both sides by 9. Cancels, this goes into the negative 3. So now I'm left with 2y equals y plus 6. Now I want to get my y's together, so I'm going to subtract that y on both sides to get it to the left. 2y minus y leaves me with y equals 6. And that's my answer. Last thing that you could do here, just to double check all your answers, one of the reasons that I really like algebra is you could 100% make sure that your answer is correct by plugging it back in. So what I would do here is plug 6 in for wherever I see a y in my original equation. When I calculate this out, I see it's balanced, I get 9 on both sides, and I know I'm good to go. So the last thing that we're going to talk about today is when an equation doesn't have one single solution. So in our last example, our variable had to be 6 to balance that equation. If it was any other value, even if it was like 5.99999, it wouldn't work out. But sometimes it's not always the case. An equation might have no solutions, and you would represent that by this symbol here. Or you could have infinite solutions, which sometimes that's referred to as the identity equation. So in an example, or how you would see this problem is typically by asking the question, is the following equation always, sometimes, or never true? And what that means is always true would be infinite solutions, sometimes would mean you get a number like x equals, so again, like that first example that we just did, and never true means there's no solution. So let's look at example A, go through, solve this equation, and see what comes up. Here I have 2 times 3x plus 5 equals 6x plus 8. Since I divided to get rid of the parentheses in the last example, here I'll distribute. So I distribute that 2 to both terms, and now I'm left with 6x plus 10 equals 6x plus 8. I'm going to subtract the 6's on both sides. They cancel out because they're on both sides of the equation. And I'm left with 10 equals 8, which is weird because obviously 10 and 8 are not equal to each other. So if you get a situation like this where you simplify everything down and you get a statement that's not true, this would indicate that you have no solutions, or in other words, this equation is never true. So again, what that means is I could literally plug in any value for x in that original equation, and that equation will never be balanced. So in our next example, we have 12 plus 3x minus 7 equals 6x plus 5 minus 3x. So again, let's just go down, solve this equation, and see what happens. So I have the 12 and negative 7. I could combine like terms on the same side first, so I'm going to do that. That 12 and minus 7 will combine to give me 5 plus 3x. I'm going to combine the x's on the right side, and I'm left with 3x plus 5. By the properties of addition, I could flip this around. 3x plus 5 is the same thing as saying 5 plus 3x. And now what I notice is I have the same exact equation on the left and right side. So when I'm solving and I get to this type of situation where it's the same exact equation on the left and right, this is what we would call the identity equation, or always true. So conversely to example A, I could plug in literally any value for x, and that equation will always be balanced because it's the same equation.